Hello students, welcome to this module on refrigeration and air conditioning. In this session, we are going to know about assembling compressor and test overall efficiency.
Objectives. Assembling a commercial compressor entails precision in combining components like motors and valves. Alignment, sealing, and electrical integration are crucial steps, followed by stringent quality checks. Testing overall efficiency involves assessing factors like flow rate and power consumption, ensuring the compressor meets industry standards for peak performance. By the end of this exercise, you will be able to keep the components to the workbench. Check the components before assembly. Start assembling the compressor. Check and test overall efficiency. Let us now take a look at the tools, equipment, and consumables needed for assembling a compressor and test overall efficiency. Manifold gauge set.
Open double-end spanner set.
Socket set. Torque wrench. Circlip plier. Ring plier. Valve key. Commercial reciprocating compressor 1 set. Bunion cloth as required. Compressor oil as required. Gasket tools or sizes. Crankshaft seal. Lapping plate and paste. V-belt required size. Sandpaper 1 paper sheet. Tray 1 number. Hollow punch 1 set. Scissor 1 number. Charging hose 2 numbers. Pulley puller 1 number. Now let us assemble compressor and test overall efficiency. Check the components before assembly. Cylinder head, valve plate, ring, G-pin, gasket, piston,
O-ring.
EPR valve, connecting rod, gasket, fitting, rotor, housing, spring, sump. Cylinder bore should be free from wear, scoring, and scissor marks. Recondition, replace if found with defects. Reconnecting rod should be free from bend and twist. Recondition if found with defects. Piston groove side clearance should be within specification. If excess, replace the piston assembly. Piston ring end gap should be within specification. Cylinder head should be free from distortion. If so found, then replace. Crankshaft journals should be free from wear, scoring, and scissor marks. If found, replace. Crankshaft should be free from bend. If found, remove the bend. Crankshaft bearings should be free from wear. If so found, replace the bearings. Check the oil pump rotor wear Check clearance. If found with excessive clearance, replace the pump assembly. Assemble compressor. Fit the crankshaft to the housing. Fit the connecting rod to the compressor piston with the help of G-pin. Position the circlips in the circlips groove of the piston. Use a circlip plier. Fit the oil ring, compressor ring in the piston groove. Use a ring plier. Insert the piston assembly into the cylinder bolts. Use a ring plier. Tighten the connecting rod cap bolts with specified torque. Keep the cylinder head gasket, valve plate, and cylinder head in position and tighten the bolts with specified torque. Fit the EPV valve in its position and tighten the bolts. Fit the sump with specified torque. Test the overall efficiency of compressor. Stop the compressor if it is running in presence of the instructor and bypass the low pressure cut out switches electrical contacts. After the vapor pressure equalizes, check and ensure the gauge lines are leak-proof. Close the valves of gauge lines and ensure both compound and pressure gauge read 0. Now open the gauge valve and record the ideal pressure of gas. Check the crankcase oil level is up to the mark. Now close the suction valve and operate the compressor for few minutes. When the suction pressure drops to vacuum 600 mm Hg, check the value of the compound gauge. Record the related discharge pressure readings by pressure gauge. Also, then stop the compressor. Check the shaft seal for any leakage of oil. If the suction gauge vacuum breaks or discharge gauge pressure drops, it is indication of leakage of valve seatings causing of inefficiency of the compressor. Observing the suction vacuum remains and discharge pressure also constant, it indicates the efficiency of the compressor. Open the suction valve, remove the bypass of electrical contact to the low pressure cutout switch. Start the compressor and operate the system. Record the suction pressure and discharge pressure in respective gauges in table 2 of record sheet. Find the operational compression ratio, that is, the discharge pressure divided by suction pressure. Fill up the tables which are given in the record sheet.
Assembling a commercial compressor demands meticulous integration of components like motors and valves, emphasizing precision in alignment and sealing. Testing overall efficiency involves scrutinizing factors such as flow rate and power consumption, ensuring the compressor achieves optimal performance and meets specified criteria for industrial applications. In this topic, we came to know about how to keep the components on the workbench. Check the components before assembly. Start assembling the compressor. Check and test overall efficiency. I hope you all understood the process of assembling compressor and test overall efficiency. Thank you, students, and let us meet in the next session. Bye.